Hello, hi, good evening, good morning, good afternoon, as per your respective time zones. Hello, everybody. I am Bharat here with our next day, another day of our course, Network Basics. And today we are going to discuss about another few interesting things in terms of our network, right? We are going to talk about various different topics today. I will be taking you a walkthrough of all those particular topics. I'm Bharat over here signing in today for our next topic within our domain one, networking basics. Today, guys, we are going to discuss about routing and switching. Why routing and switching is one of our major topics and why we have dedicated entire session to it. Just understand this particular thing in a very simple manner that routing and switching are two different things or two things which basically are helping us to communicate. Like you and me are connected together. It is because of the route which we have, which our devices have chosen, right? And if you are able to communicate with your devices within your networks or within your adjacent networks, that is because of switch as well, right? So we are going to talk about both what is routing, what is switching. We are going to discuss routing bit in detail, where we'll understand what is dynamic routing, what is static routing, right? Then we are going to talk about various different types of switching like circuit switching, packet switching, message switching. We are going to talk about all three of them. The two major ones, yes, we do know that there are circuit and packet, but we'll talk about all three of them. And then we'll talk about like what are various different types of protocols which are being used in routing and switching, right? So that is basically the agenda for our today's session. And I believe that particular today's session is going to be a bit more interesting for all of us because this is something which is going to help you to understand how packets or how data in our network basically travels when you are connected in a local network and when you want to connect to one network to the another network, how the transmission basically takes place. That's what today we are going to discuss about. So routing and switching, let's start with routing. Let's understand first of all what is routing and where it has been applicable, right? So before moving towards the guys, yes, routing and switching, I will just like to basically give a quick reconnect that why it is necessary, right? Now just imagine that how millions of networks across the globes are connected from one single network, right? Understand it in this way. And we as a network administrator or we as a IT person, we should know how these interconnected networks talk to each other and share data and how information is transferred from source to destination and that too very instantly, right? So there are multiple things which are working together to facilitate the communication across the different networks, including the internet as well, right? So we will be using routers, routing techniques, we will be using switching technologies, all these things together in order to basically understand how these things works, right? And especially when we do talk about routers basically are the workhorses of all the internet works, including the internet, right? And we need to understand routing and switching basics no matter what kind of network we do support, right? We need to understand that it is as important as remembering about the networks, right? So far you have understood in our previous classes, you have understood what are the basics of network hardwares. We did talk about various different types of network devices. We did talked about OSI model in detail. We did talked about yesterday the TCP IP model. And over here today we are talking about the routing and switching. So the very first part, routing, also known as network packet routing. So routing is basically, guys, a concept, right? Let's say if all of our networks are adjacent to each other, right? Let's say your network is adjacent to a network of mine, then a switch between your network and my network would be fine, right? But there are chances that we want to access the network outside our network, right? We want to access a particular type of network that is outside of our network. So in that case, guys, what we should do? in that case, we should go for like which type of network can be an example. Let's say I want to connect to a network which is not part of my internal network or which is not part of my adjacent network. For example, internet. I want to connect to internet, right? So that is the major reason where routing is being needed, and routing is being provided by routers to access those type of networks, right? So routing itself, it's a process of selecting the best route, right, for transferring a packet from a source to its destination network. Now, let's say I want to send you a data. You are sitting in, let's say, LA, United States, and from here in India, from Delhi, I want to send you some data. Now, there can be multiple ways from where that data can be reached to you, right? There can be a way that data can be reached to you, let's say via going through United Kingdom and then reaching you, or there can be a way that data might basically reach to you via, let's say, UAE, right? So in both of the cases, data is reaching to you, but which should be the best part? That should be decided by under routing, right? So a router basically is a device which applies the appropriate algorithms to generate and maintain an information base, okay, about all the network paths it is connected to. So router will be responsible for various different routing matrices, and how it will be deciding, like how I should decide. There are certain parameters, right? There are certain parameters which can be used for considering the best path. Like I mentioned, routing uses the best path. So there are certain parameters for considering the best part. So those parameters can be, guys, like the bandwidth, of course, the reliability of the path, and the communication cost, right? All these things basically can be the part where evaluating all of our available network paths to determine the optimal route for forwarding the packet can be decided by the router, right? So once the optimal route for a packet is assigned, we will be using the packet switching techniques to transport the packet from the source to the destination host, right? So the action of forwarding a packet from one router to another router is known as something which we do call as a hop. Routing is a process of determining the best path for the data to travel between the devices on a particular network, right? So a data to travel between two devices on a network or on two different networks, let's say from your device to my device, if the data is there, that's what we do call as, like, to select that particular path, that's what we do call as routing. And when a device basically wants to send the data to another device, that particular data will be broken into these small packets, and then it will be sent across the network. And each packet will be containing the source IP address and the destination IP address among. So we do use routers as a network devices that basically are responsible for routing the packets between two different networks, right? So that's where router comes into the picture. Router uses something which we do call as routing table, right, to determine the best path for the packets to reach to its destination. And then the routing table contains the information about the networks, like the routing table basically which I was talking about. It contains the information about the different networks that the router is connected to and the best path for the packet to reach to a destination network. That's what routing table will be helping you with. The next part, guys, is switching. Now switching, as discussed, like switches. In organization these days, we are using switches to interconnect multiple different devices, right? So that's where the concept of switching comes into the picture. The concept of switching basically will be the concept of switching will be like of forwarding the data packets between devices on the same network, right? Let's say you and me are connected to the same network, and like us, there are 600 people right now connected with us almost. So for those 600 people to be connected, if I want to send the data to one particular person, I will be using the switching processes in order to share that particular data, right? So when a device wants to send the data to another device on the same network, again, the data will be broken into smaller packets and will be sent across the network, right? And switches basically are the network devices that are responsible for forwarding those packets between the devices on the same network. How it does? A switch basically maintains a MAC table, also known as CAM table, MAC address table, which contains the information about the MAC addresses of all the devices which are connected to that particular switch, right? So when a packet has been arrived at switch, let's say I am a sender, I'm sending a packet to your destination. So when a packet has been arrived at the switch, talking about the switches, guys, switches, as I mentioned, it maintains a MAC table. So let's say I want to send a packet to a data to you, right? My data will be broken into the packets and it will be coming to you via a switch. So as soon as the basically the packet basically arrives at the switch, right? The switch will be looking into the MAC address of the destination device. That should be your MAC address. And then that particular MAC address in the destination device, its MAC address it will be finding in the CAM table or the MAC table, MAC address table, and then will be forwarding the packet to the appropriate port. To explain it better, let me just draw it and explain it to you. Now, for example, guys, this is a switch where multiple devices are connected. There are 6 ports, right? On each of 6 ports, there are devices like A, B, C, D, E, and F. So there are devices A, B, C, D, E, and F. 6 devices are connected to each port, right? So there is a CAM table, also known as MAC address table, which will be acting something like this. Like for port 1, where there is device A, right? For port 1, where there is device A, there will be a type of MAC address, let's say A, something like this, right? We are just taking an example. And likewise, guys, it will be having port 2, where there will be B and B's MAC address. Then there will be port 3, where there will be C and C's MAC address, right? So this type of MAC address table will be maintained by every switch. Understood? Now let's assume that A wants to send the data. A is a device, a laptop. On A there is a device which wants to send the data to someone sitting on F, right? Now it is within the same network I'm talking about. Now, as soon as I want to send the data, my data will be coming in forms of packets to the switch. It will be coming to the switch. Now, as soon as the packet arrives at this particular port, right, the switch will go and will check in the MAC address table that what is the MAC address of F, right? What is the MAC address of F, and belonging on that particular MAC address, it will choose that particular port number. Let's say port number is 6. So it will be transferring the data to the port number 6. That's how a switch basically works. This is how a switch works. So when a packet arrives at the switch, switch looks up at the MAC address of the destination device in its MAC address table and forwards the packet to the appropriate port within that particular table, right? So this is, guys, what we do call as a concept of switch, and this entire process is known as switching, forwarding the data packets between the devices on the same network, right? So this is what we do call as switching, like transmitting the information over a network to its destination network device. Now switching can be of multiple types. We are going to discuss them bit in detail, and we are going to talk about the routing and switching. Okay, so let's do talk about the difference between the routing and switching here itself. Then we will be talking about like static dynamic routing, and then we'll be jumping into the types of switching and so on we'll talk about, right? So let's do talk about what is difference between the routing and switching. So as per the OSI model, guys, as I mentioned, router basically works over the IP address and switches basically works over the MAC address. So when we do talk about switches, switches are layer 2 devices because they works on MAC addresses, and routers are your layer 3 devices because they works on network layer, right? They works on IP addresses. Understood? So that is the first concept. Switches L2, routers L3, right? That means L2 layer 2 MAC address switches, and routers L2 MAC address switches, and L3 basically it's your routers, right? So because router makes the forwarding decision based on layer 3 network addresses that are typically the IP addresses, and switches make the forwarding decision based on layer 2 MAC addresses, right? Also about switching, guys, when a device communicates with the different network through switches, right? Let's say device A of a network 1 tries to communicate to a device B of network 2, right? So it will be through, if it is through switches, it is necessary that the switch should be an adjacent switch. Let's say, for an example, there is one device in my network, and this network is network 1, right? Device A in network 1, and similarly there is device B in network 2, right? So when we do have this device A in network 1 wants to communicate to device B in network 2, and that is something via switch. So both of them should be part of one common switch in that particular case, right? They both of them should be in one common adjacent switch, and that's how they can basically communicate to each other, right? Because when data is being transferred through switches, it is limited to the existing networks because the devices in the switching, right? Because the switches use the MAC addresses, media access control addresses of the device to locate it. Now talking about routers, like difference we did talk about. Now that image which I showed you where there are two different devices from two different networks, they should be part of existing networks itself. Then only they can basically communicate with each other, right? But when we do talk about routers, right? Routers are designed to interconnect multiple networks. right? Routers are themselves being designed to interconnect multiple networks. So what I can do up over here is I can put a router in between to connect these two different switches, right? To connect these two different switches. Now, device A of network 1 is being connected via my router over here, which basically will be forwarding the data to the network to device B, right? This is my device B and this is my device A, right? And there is this router in between. So this is basically the part of routing. So routers basically they use a map of networks on to make the decision on where to forward the data packets, right? First thing that is important for router. And if there is something next to router, right? So routers, first of all, primarily determines their next hop for data. Let's say if I am the router and if I need to forward a message to you, so I will be finding my first hop to reach to you. That might be one of my salesperson, right? Or that might be one of my operations person to reach to you, right? So if I am a router, I will be determining the next hop for the data. And as a router, basically router will be able to read the port number where the data is being sent, and it can determine not only the data's destination by using the IP address, but it can also determine what kind of data it is trying to transmit, because routers are that much intelligent, right? So if there is any sort of broadcast, these broadcasts can be either forwarded or can be either dumped. It totally depends on the router settings, right? So that is basically about router. So that is major difference between the routing and the switching. Now we are going to deep dive within the routing first thing. Like you can see the topics. We'll talk about the dynamic and the static routing. And then we are going to talk about switches, right? The types of switches, that is circuit, packet, and message. And that's how we will be summing up after discussing the protocols being used in both of them. So the concept of routing, again, to choose the best path, and it chooses via IP addresses, right? So that is majorly the part of routing. Switches basically communicates the data between two devices on the same network. Now let's do talk about the static and the dynamic routing, right? So we'll understand first of all both of them, then we'll talk about the comparison of both of them, right? In case if anyone is having any sort of audios or any sort of problems within the audios, I would recommend guys check your network. From my side, the connection is optimum and it is working good, right? So let's start with static routing, dynamic routing. People do also call it as static IP routing and dynamic IP routing, right? So as the name suggests guys, the dynamic routing, like dynamic IP addressing, right? DHCP kind of thing. So is the technology of, basically you can say, is a technology of choice in a larger network environments. When you do have a very large complex network environment, you will be always having dynamic routing, right? As a network professional or as a network administrator, you should basically understand the dynamic routing technologies and how you can implement them, right? You should understand the dynamic routing technologies and how you can implement them so that it can help you in your routing environments of all of your sizes and types, right? So over here, we are going to ensure that each device is properly identified on the network, and it is basically common for routers to use manually configured routing entries as well, right? Even if dynamic routing is used in your network, static routing can be also basically used to maximize the routing's efficiency, right? So for a solid understanding of static routing, anyone who is working as an administrator, you will be basically knowing this particular part, right? That static routing is always being monitored, governed, and done by network administrators, while dynamic routing, it is basically done with the help of routers, right? So a solid understanding, if you are a network administrator, you should have a solid understanding of static routing for sure, because that will be your job and responsibility to do static routing, right? So let's start with static one first. So static routing basically uses routing table entries that were basically entered manually by the one person, that is network administrators. So static routers do not change unless the administrator changes those particular routes. Let's say you sit in a cab, right? I'm just taking one example so that you guys do understand static and dynamic routing. There is a destination where you want to reach, destination X, right? Now you sit in a cab. There are two ways to reach to that particular destination. The one way, you sit in a cab, you ask the driver to take the direction to the X, right? You do tell the driver to take the right, then left, then right, then go straight, then from a roundabout take U-turn, then take left, then take right, and that's how you do reach destination X, right? Or there is an another part where you do just sit in a cab and ask the driver to take you to the destination X, right? You do not tell him the path, like the path, how he has to basically take you to destination X. Now the driver automatically decides himself to take you to that particular destination X by choosing any particular way which he wants, right? So in these two ways, the one part where you were governing the driver, that you have to take straight, left, right, and then so on, that is what we do call as static routing. You as an administrator, you were entering the path manually, right? And the second part where you just sit in the cab and ask driver to take you to destination X and you rely upon the driver's route, that is what we do call as dynamic routing. So static routing, repeating again, static routing uses the table entries that were entered manually by the network administrators, and these path does not change until the network admin changes them, right? So static routes basically remain in the routing table and the traffic is forwarded. Regardless the destination is active or inactive, the traffic will be forwarded from the same route. Characteristics, if I do talk about static routing, it will be basically more useful in small networks where there are no redundant routers and the topology of the network is not going to be changed, right? That is first thing for your static routing. And it is always basically commonly used even when it is not desirable for your routers to use the bandwidth to update each other, right? With the dynamic routes, right? Where you do need your routers to use low bandwidths, you go for static routing, right? So this is particularly the part where there is very little bandwidth available or your routers must dial each other on demand to pass the traffic, right? Across like a phone line, like there was earlier demand dial routing, right? Then basically a router in static routing I'm talking about, a router will always trust the admin configured static routes over any route it learned dynamically from other routers. Let's say when one router communicates to another routers, it basically checks with the route which another router is basically having, right? So if it was dynamic routing, it would have automatically updated the existing route to the better efficient route. But since it's a static routing, it will always rely on the admins trust, network admins trust, because static router basically have the entries which are being configured by the admins, right? And a device basically with a static default gateway, right? A device which is configured with a static default gateway cannot switch to any alternative gateway even if one exists, right? It will be always static to one single gateway. Understood? So that is guys what we do call as static routing. In static routing, the static routing tables are there and these are manually configured on the router. These are basically fairly easy to set up and are sometimes basically used on very small networks as discussed. And as long as the network is relatively unchanged, right? Static routing tables will be ideal for any sort of connection within that particular border of that particular router, right? And it can basically help you up over there, right? Now, as I mentioned on day one as well, everything comes with advantages and disadvantages, right? Now, if I do talk about the advantages of static routing, it does not cause any additional network traffic by sending out table updates to any other routers, first thing, because it is having one same thing up over here. That is, it will not change any sort of entries in the routing table. It provides extra security from other systems rogue routers, right? Let's say if there is any fake router which is intentionally trying to send a fake information to your autonomous system of your router to update the entries in your routing table. So that can be basically not be applied up over here because static routing does not change any sort of entries in your routing table. And of course, in your static routing tables, one of the another advantages basically is that the routing table in static routing can be configured to cover only the necessary portion of your network, right? That way, your router will not expend any sort of resources of maintaining its routing table anymore, right? So these are like few of the advantages. Now, if I do talk about the disadvantages, again, the biggest disadvantage of static routing tables is that they always require manual maintenance, right? Static routing always require manual maintenance and any sort of network changes needs to be updated manually on all the routers that are affected by that particular change, right? And of course, since it has been maintained and managed by humans, it is prone to the configuration errors, right? And it is less efficient than dynamic routing. These are like few of the disadvantages of static routing tables, right? Because when one path is being given, it's not necessary that the same path will be always the efficient path. Sometimes the intelligence of your router can find more efficient path to reach to that destination, but in terms of static routing table, it will not be updated, right? So these are few of the disadvantages of static routing table. Next is guys dynamic routing. First of all, let's understand dynamic routing, then we'll proceed with next. So the routers that support dynamic routing, they do perform one sort of discovery that is we do call as route discovery operations, right? In which they do try to build new and update the old routing tables themselves by specifically designed softwares, right? So there are softwares within the router which basically tries to find out or create and update the routing tables by themselves, right? That's what dynamic routing basically does. So in dynamic routing, routers basically themselves do create the routing tables and decide the path through which the data should be passed, right? So the router transmits the data to the adjacent router, right? Providing the information about the networks that they are currently connected to. and the networks that they can reach to, and then the adjacent networks basically will be giving the best path to reach to their particular networks, right? So in dynamic routing process, the router entries are created automatically, and there is a dynamically built routing tables that can show more accurate picture of your network because they are updated more often than the static tables, right? And why this is because the routers in dynamic routing are not the administrators who updates the tables, right? Because in dynamic routing, the routing tables are not being updated by the administrators, right? So let's take an example. If network is having more congestion, right? If network suffers a traffic congestion or if any device fails, so the router running in dynamic routing protocol, it can automatically detect the problem and then can calculate a different routing path, right? That is one major part. And this feature is a huge advantage on your large networks that have many routers and multiple paths to each endpoints. So I'm talking about one simple thing. Let's say this is a destination where you want to reach, and this is your source. Okay. Now in static routing, you will be deciding the path that it should go like this, then from here to here, and that's how it will reach to this destination, right? In static routing, I'm talking about. But in dynamic routing, you will be relying on your router to basically choose the path that how it is going to reach to the destination, right? That is dynamic routing. In dynamic routing, you rely upon the router to create and automatically choose the path to reach from one source to another destination. And in static routing, you as an admin, you will be giving the path that to reach from this source to this destination, this will be the path. So I was talking about, guys, like the advantage on large networks, how if there are multiple paths to each endpoint, how your routers can automatically detect the problem and calculate a different routing path if a device fails or a router, if a device fails or there is a traffic congestion. So there are dynamic routing protocols that are often basically being categorized by how routing data travels across from router to router. So there are multiple different types of protocols in routing, dynamic routing. So especially if I do not say dynamic routing, these are routing protocol types, right? There are multiple routing protocols like distance vector protocol is there, right? Link state protocol is there, hybrid routing is there, path vector protocol is there. Multiple different types of protocols are there. So if I do compare both of them, dynamic and static, in static, manual entries for in your configuration files, and then these files are loaded to your router. When your router starts, you will be using static routing when you do a few devices on your network. And why you will be using static routing? Because it will minimize the time it takes to create and maintain all the configuration files, right? And dynamic routing uses special software designed for your routing devices. And these are the software which automatically creates these routing entries for the router to connect all the devices on your network, right? And generally in organization, there are systems that support both static and dynamic routing. So static will take the precedence and then dynamic basically will be used to configure to communicate the data, right? So this is team what we do call as static versus dynamic routing. So advantages of dynamic routing basically, as we already have discussed, that dynamic routings can basically help us to proceed fast. Like one of the biggest advantage would be it can automatically detect the problem and it can resolve the problem by changing the path, right? That is one major thing. Second, it does not advantages, it does not basically have any sort of manual interference. So these paths can be regularly updated and can be chosen based upon your best optimum resources, right? So these can be like few of the advantages. Disadvantages of dynamic routing can be that your network bandwidth will be required extra, because to create, maintain and update these routing tables, router has to communicate between each other. First of all, your extra network bandwidth will consume. It will be a bit less secure, because if there is any sort of rogue router, right, a fake router in between which is actually trying just to send some fake entries to your autonomous, that is the automatic system of your router. So if your router basically updates that routing path, then that can be basically a damage to your network, that how your network communicates to those particular devices. So these can be few of the disadvantages of dynamic routing. So this is guys your dynamic and static routing. So let me just show you how you can see your routing tables in your network and how basically it can help you to view those particular parts, right? So let's basically have a look. So there is one command guys that is with the name of route. If you use route print, this is my routing table, right? That is my routing table entries, right? Can you see the gateway and all these particular parts? It does have the IP addresses of those particular devices and my networks, right? If you want to change any particular route, you can use the command instead of route print, you can use route change. If you want to basically go for any sort of, for say, persistent routes, right? Any sort of routes which you have specifically made persistent, even if your router does get reboots, these routes will be same. You can use route hyphen p command, right? It will be helping you to create persistent routes. If you want to add a particular route, route add. If you want to change one, route change. If you want to delete one, route delete, right? And if you want to delete everything, like all the entries from your routing table, route hyphen F. It will clear the routing table of all the entries. In Linux, route is the only command you do use. I'm just talking over here. This is the command for Linux, route hyphen N. It will be displaying the IP addresses instead of host name, because if you by default only give the route command in Linux, it's about it's not about Windows. If you only give the route command in Linux, it is going to display all the routes but with the host name. But when you give hyphen N in Linux, it is going to basically show you all the IP addresses. If you give hyphen RN, route hyphen RN, it is going to display the routing table with R option, right? That will display the IP addresses with the host name with the N options, and routing will be R will be displaying all the options for the routing table, right? And then you can use, if you want to see all the entries, you can use IP route list, right? It will display the entries from the routing table. This is the command for Linux, not for Windows, right? So this is guys what your device does have. Let me just explain you these particular columns. So the first part is your network destination, right? That is your network ID or network destination. The next one is mask for that particular entry. This is basically the first hop. Gateway is always the first hop address which it stores. Then there is the local address from where the request is generating, and the route in particular hops, right? What is the total route cost? You can see it in metric. Clear? So this is all about team types of routes and routing. You can use route print command in Windows and route hyphen n command in Linux to see all of your routing parts. There is one concept, autonomous system. Do you guys know what is autonomous system in routing? It is one of the roles. So autonomous systems or routing domains, basically we do call them. These are self-contained networks or group of networks that are governed by a single administration, right? So as an autonomous system, one can connect to another networks or other networks or other autonomous system, but they does not share the routing information outside of that autonomous systems, right? So router can play various different roles, especially three major roles in autonomous systems: interior router, exterior router, or border or edge router, we do call it, right? So this is guys what we do call as autonomous system. This is about routing. Routing we did discussed, and then with that particular routing we discussed dynamic and static. Static your network admin will create, dynamic your router itself will choose. And to see how it is, we did saw it in CMD. So let's get started. Let's continue for our part towards the next type of learning where we are going to talk about multiple different topics in terms of switching, right? Couple of minutes before we did talked about all routing, dynamic routing, we did talked about static routing, we did talked about the tables, the advantages, the disadvantages. Now let's do talk about the switching. Talking about switching now, switching as we discussed already guys, that switching is going to be one of the parts where like two devices basically when they do communicate, right? Two devices when they do communicate between each other, there is a switch in between which is using a switching technique to transmit the information over a network to the destination network device, right? Generally, there are multiple, like majorly there are two important types of switching techniques. The one is circuit switching, the another one is packet switching. But there is one more, that is message switching, which is relatively not being used that much. But yes, it's an important one. So we are going to discuss this one as well, right? So let's do talk about these three types of switching techniques. So the very first one, that is circuit switching. So in circuit, basically, as the name suggests, in circuit switching, there is a circuit basically being created already, right? One endpoint creates a single connection to the other endpoint. Now can you see user 2 is having a switching technique which is circuit to user 3, right? And this particular single connection to another endpoint is known as circuit, which refers to that connection bar path between the endpoints, right? So it's a type of switching that basically establishes a dedicated communication path between two devices. That's what we do call as circuit switching, right? And this dedicated communication path is known as circuit, right? And it will be reserved for the exclusive use of those two devices during of their particular entire communication, right? So in circuit switching, basically a call setup basically phase occurs before the data transmission begins, right? This is the same thing which happens in telephone networks. Now, if you want to call someone, remember I mentioned that there is a protocol SIP on the other day. I did mention that there is one protocol SIP, session initiation protocol, right? Something similar to that concept. Over here, if I have to send any data to you, and if I am over circuit switching, first of all, a connection to you will be checked, right? And that particular path will be fixed up till our communication is happening, right? So in circuit switching, a call setup basically phase will occur before any transmission begins. And during this call setup phase, the network will be establishing a dedicated circuit between two devices, right? So any sort of communication which is going to happen from device A to device B, right? Now let's say this device wants to communicate with this device. So before any sort of data transmission, this path is basically being established, right? Now once it is being established, now data transmission will happen. That's what we do call as circuit switching. So circuit switching is basically used in telephone networks where it has been a dominant switching technology for more than over a century now, right? So that is what we do call as circuit switching. Now, once the circuit is established, that means this route is established, then the data is transmitted through this particular route as long as the circuit is active, right? And a dedicated bandwidth to that connection is given until it is this particular circuit is not needed anymore, right? There is, and even once it is being done, right? Let's say I wanted to send you one file, a circuit established the connection. Now it is basically the file is being sent. Now circuit is being closed. Now next time if I want to connect to you, it's not necessary that I might be on the same path. It can be that now I'm using this particular part to you, right? So there is no guarantee that the data will be transmitted to the same path through the network in different session. The path which was being chosen in session 1, right, will not be the same path. There is no guarantee that it will be the same path in the session 2, because session 2 it will again find a circuit and it might be a different circuit altogether. Now after circuit there is a packet switching. So packet switching basically it's a part of a type of switching technique which is being used in packet switched networks, right? So packet switching is a type of switching that breaks one single message. Now this was my message. It breaks the message into multiple different packets, right? It's a packet switching is a type of switching that breaks the data into small packets and then transmit them across the network. Now one packet can be from a different path, another packet can be from different path, another packet can be from different path, right? So each packet contains the header that identifies the source and the destination packet, like that contains the source and the destination of the packet, and as well as each packet contains other information like the sequence number and the payload size, right? Now over and all, if I do repeat it again, what happens in packet switching is when data is being basically first of all broken into the packets, and then each packet is transmitted individually across the network with the corresponding information of source and destination packet, as well as information like sequence number, the payload size, all these things, right? So in packet switching, packets are transmitted. Each packets are transmitted independently across the network, and then before it reaches to the destination, each packet has been reassembled, right? It has been reassembled at the destination device, and that's how you do receive your message, right? Now, packet switching basically is used in your computer networks where there is always a dominant switching technology, and this particular packet switching technology we are using from early 70s, 1970s, we are using this particular technology of packet switching. So again, repeating it one more time. So in packet switch networks or packet switching, the data that is to be transmitted, the data that is to be transmitted is broken into the packets, and then packets that move into the sequence through a particular network. Each packet basically chooses their own best route available at that particular given time, right? Rather than following a established circuit. Like in circuit, if you do remember, I did mention that there will be a dedicated path being decided first, and on that dedicated path, you will be sending data. But in packet switching, there is no dedicated path. Like if I want to send it now, my data will be broken into the packets. Each packet will be deciding the best way to reach to the destination, and then it will be choosing that way and it will be going through it, right? If you send the same data 30 minutes later, at that time, what will be the best path for that particular packet to be reached? It will be choosing that, right? So rather than having established circuit path, each packet takes the best route available at that given time, at any given time when data has been transferred, right? And each data packet basically contains all of the routing and the sequencing information that is basically being required to transmit it from one endpoint to the another, and after which data is basically being reassembled, reorganized, and it is basically being created in the same way how message was being sent. Now this sent message is my part broken into three ways. Each of them is individually choosing their way to reach to the destination, right? Once being reached to the destination, each of them are being combined together, being reassembled together to create the same message which was being sent. Now, packet switching already assumes that the network is constantly changing, right? And the adjustment is always being needed to made to the compensate the network congestion or broken links. That's why it does not basically choose one path and then sends the data to that path. It always basically go through the ever changing network of yours, right? So that is what we do call as packet switching. Now there is one more concept, that is message switching, which you might not find in most of the books. But message switching is a technique where the entire message is transmitted without any particular break, right? Now there is message one, there is message two. Now message one, can you see it is being already decided that it is going to this particular way and it will be reached, right? For message two, this is the way how it is going to be reached, right? So this is basically what message switching is all about. So if I do explain message switching, it is a type of switching that is similar to your circuit switching. But instead of like in circuit switching, repeating it again, a connection was being established from one endpoint to another endpoint. But in message switching, instead of establishing a dedicated circuit, messages are basically being stored and forwarded between the intermediary nodes until they do reach their destination. Now I have created a packet for H. right? Now I will be sending the data. Now let's say I have created a packet for H. H is over here. Now I will be keep on sending the data until and unless it reaches to the H, right? No matter what route it chooses, if it reaches to the H, that is my message switching technique, right? So in message switching, again, each message is broken into the smaller packets and each packet is transmitted independently across your network, just like it is in packet switching, right? It is well suited for the communication applications where transmission delay is less important than the message delivery. Over here, my major important motive is that my message should be delivered anyhow. Transmission of that particular message, if it is being delayed, that's not a problem. So in that industries, message switching will be good to use. So in message switching, again, my messages is broken into the packets and it will be sending the packets continuously to the route until it reaches to the edge, right? That means until it reaches to your destination. So it will, like all the intermediary host in between, will store and then forward this particular information. Like A sended the data to B. B will be storing that A has sent data for H, and then it will forward to C also. It will forward to D also. D will be storing data that there is a data which is being sent from the B who has received the data from A and it is for H. It will store that data and it will share to F. C will again store that particular data, it will share to E and it will share to F. And then so on, it will share it to G. Then finally, in the end, it will be reached to the H, right? So it firstly stores and forwards the information that requires bit more time, of course, right? And due to this excess of time being increased, there is no direct link present between the sender and the receiver, right? So there is no direct link which is being present between the sender and the receiver. So a complete message is basically passed across the network, right? And in this message switching, there is no limit on the block size as well. There is no as such limit on the block size as well. And the message exists only in one location in the network. And it is a hop by hop forwarding technique, right? So access time basically is being required to send the data to their destination. And each of the data will be stored in the disk of the system, right? So that's why it is rarely being used, not being used more, right? Message switching. So these are guys three different types of switching: circuit switching, message switching, and packet switching. Now let's do talk about two major of them. Like the packet switching is main, circuit switching is main. So first of all, let's do talk about the difference between the circuit and the packet switching, right? Once we are done with that, I'll come back to message. Like if you will want, I'll come back to message and packet switching. I can differentiate it between message and packet also. But right now we are going to talk about search circuit switching versus packet switching, because these two are the major ones which are being used, right? It is very simple to understand, guys, the difference between the circuit switching and the packet switching. In circuit switching, there are three phases, right? Phase one, you establish the connection first, right? Once the connection has been established, then data is being transferred, right? Step two. Then step three, the connection is being released. But in packet switching, packet, like the data is directly transferred to the destination, right? Once my data is in packet, this packet is being directly sent to the destination over here, right? It does not wait for the connection to establish. It chooses one random path, how it will be sent, and that data will be sent. That's it, right? Secondly, guys, in circuit switching, each data unit knows the entire path address, right? If there is data unit 1, it will know that it has to go through port 1 of switch A, then port 2 of switch B, sorry, port 2 of switch A, then port 1 of switch B, then port 3 of switch B, and then it will be reaching to its user, right? Each data unit will be knowing the entire path address which is provided by the source. But in packet switching, if I do talk about each data unit, right? Each data unit just knows the final destination address. Intermediate paths are being decided by the router, right? If there are any intermediate path, those are being decided by a router. I will be knowing the address of only my destination, right? In packet switching. Now, another difference which you can have in circuit and packet switching can be in circuit switching, data can be only processed at the source system only, right? This is my source system user 2, and my data will be processed over in source system 2 only, because from here I will be only deciding the path, how I have to reach, and then only it will be basically transferring the data, right? So every processing is done on source only. But in packet switching, there is assemble and deassemble, right? The package basically does get disassemble over here into pieces. Then once it reaches to the destination, these are reassembled into the entire data, right? So data is processed even not just in source and destination, it is data in packet switching. Data is processed on all the intermediate nodes, including your source system as well, right? In circuit switching, the delay between the data units is uniform, right? Because there is already a path. So what sort of delay will be there between one data unit will be uniform between another data unit, right? But the delay between the data units in packet switching, it's not uniform, right? Maybe one packet has been sent earlier, one might have caused more delay than expected, depending on the route congestion. Of course, since a path is already being reserved, so resource reservation is the feature of circuit switching, but there is no resource reservation because bandwidth is being shared among all the users in packet switching, right? Of course, circuit switchings are more reliable and packet switchings are less reliable. In packet, it stores and forwards. It uses store and forward technique, but in circuit, it is not storing and using any store and forward technique. Over here in circuit, transmission of data is done by source only, but in packet, transmission is done by not only by the source, but also by the intermediate users, right? Like the hops which are in between. So this is guys like few of the major differences. There can be n number of differences between circuit and packet, but these are like few of the major differences between the circuit and the packet switching. Message switching versus packet switching, right? That was something which I mentioned that we can talk about. So message switching basically completes this message switching which you are seeing up over here. This message switching, a complete message is passed across the network, right? In this message switching, everyone is storing it. But in packet switching, message is basically broken into small parts known as packets, right? And in packet switching, binary type is used, zeros and ones, but in message switching, entire message in terms of ASCII or Morse code or bordered code, it is being used, right? In message switching, there is no block size, no limit to block size, but in packet switching, a tight upper limit on the block size is being done. So the parts, that is the packets of the message, exist in many places on the network in packet switching, but in message switching, it only exists on one location in the network, right? In packet switching, packets are stored in the main memory, and in message switching, access time is reduced due to increase in performance as packets are stored in the disk over here, right? So that is what we do call as message switching and packet switching, right? Someone is saying that give some real-time use cases. Like if I do talk about circuit, as I mentioned, for the telephone networks, circuit switching is good. If you are establishing a call, like to initiate a call, first of all, a connection to that particular receiver should be established, whether it's reachable or not. If it is reachable, then your data is being transmitted, isn't it? So that is circuit switching. Then packet switching will be basically for the industries like computer networks, right? Where we are sending the data in terms of small packets, and each of them basically it's been sent from your source to the destination independently, and then basically is being reassembled across up over here. And message switching will be basically for the applications where your transmission delay, that means the delay in the message is less important than the message delivery, right? Like usually your delay in the message should be equally important. If you are sending it something right now, it should be reaching to you right now itself, right? Instant messaging we do call. But if you are using a messaging technique where the delay is not that much important, but the delivery you need to be assuring once. So at that particular part, you will be using message switching. So these are guys, three different types of switching techniques: circuit, message, and packet. The last topic for today, that is the protocols which are being used in routing and switching. For routing guys, we are having multiple different types of protocols. Like you can see, border gateway protocol is there, open shortest path first is there, EIGRP is there, enhanced interior gateway routing protocol. There is routing information protocol. There is intermediate system to intermediate system, ISIS protocols. These are few of the commonly used protocols which are being used for your routing concepts, right? These protocols are being used for your routing parts, right? Each of these particular protocol will be used like for different organizations having different requirements. These particular protocols, one of these particular protocols will be chosen which can help you to route your traffic from one network destination to another network, one network source to another network destination. And each of these protocols which you are seeing, they will be depending on various different factors. Like it can be based upon distance vector, how much distance is there from one to another. It can be link state, whether link is up or not. It can be a hybrid routing protocol. It can be a path vector protocol, shortest path first. So it will be deciding on various different factors. Your routing protocols will be decided. Like you want to go for the shortest path, right? You might basically go for open shortest path, right? If you want to go for distance vector, like the distance between one switch network to another switch network, at that time if you want to calculate based upon the distance, you might go for border gateway, right? Or you might basically go for intermediate system to intermediate system. So different ones you will be choosing in terms of routing up over here. And then in terms of switching, if I do talk about, in terms of switching, you will be using protocols like STP. Like why I'm using protocols in switching is, let's say, let's assume an example up over here. Now there is device 1, there is device 2, there is device 3, right? Now each of them are connected somewhat like this. Now if I am sending a packet from this particular user to this user, it can be sent like this directly over here also, and it can be sent via this also, isn't it? Like I can send to this is A, this is B, and this is C. Now if A wants to send the data to C, A can directly send it to C, or A can send it to B and then B can send it to C, isn't it? Now there can be a way where, if same way C wants to send the data to A, it can send it via directly C to A, or it can send via B to A. In either of the cases, the data is going to collide, right? Like so, same path is being used for sending and receiving. So there might be basically like collisions. To avoid those collisions, we use protocols. Even there is more than one redundant link. Like when A can directly send it to C, why to keep this link active via B, isn't it? So we do use protocols like spanning tree protocols, right? Which can help us to prevent switching loops in the switches, right? So wherever there are redundant paths, that means duplicate paths between two switches, or whether either of two switches are connected using two different links, or there is maybe a hub in between which will broadcast between them. So there might be a case then both of them basically might create a storm on the same redundant path, right? So that's why we do use protocols like STP. VLANs, we already have discussed VLANs. VLANs are like logical grouping of your ports on your switch, right? For example, if this is my switch, right? I can create a logical grouping of A and B. I can create a logical grouping of D, E, and F. Now, this is network 1, AB. C is a different network. D, E, and F can be a different network. So now connection can be between one VLAN to another VLAN also. Now within VLAN there are multiple devices, right? So what I have done is I have done the logical grouping of the ports on the switches. That's what helped me to create a virtual LAN, VLAN, right? Now each of these particular groups which are on the same switch can have different networks also, right? Like over here, A and B can be a sales team. They might have a different network. D and F can be security team, different network. C can be management people, different network, right? So on the same switch, which should be on the same network, I have used VLAN to segregate and separate into smaller networks. That's what we do call it as VLANs, right? Now nodes which are placed on these VLANs, they can communicate with each other only. A and B can communicate with each other. D, E, and F can communicate with each other. They cannot basically communicate with the nodes that belongs to other VLAN until and unless the connectivity is being given. Multiple VLANs are being given on the same switch. So these type of things, guys, it can use VLANs, it can use protocols like link aggregation control protocols or hot standby router protocol. These are few of the switching protocols and these are few of the routing protocols, right? So this is all about your routing and switching. Again, if I give you a quick overview of these things, your intranet, your internal network communication, switching, your external network communication, that means internet or any other network which is not connected or near to you, maybe you sitting over here and you want to communicate to a different network of a different organization. So at there, routing will be used, right? Routings can be dynamic and static. Dynamic, router will itself decide. Static, admin will decide. Types of switching, circuit, entire path will be decided. Packet will be broken into the pieces and sent. In message, it will be stored and sent, right? And different protocols which we discussed for all of them.